Okay, good afternoon, everyone. We typically have a large number of folks who prefer to watch this recording rather than attend in person, and that's fine. We understand folks are very busy, so this will be recorded. We did have about 25 folks registered, but most folks here will be watching the recording. But for those of you who are joining us real time, you're welcome to put any questions in the chat. So I'm one of the owners of A3 Global, which includes Hybrid Battery 911 and NuVant Systems. And we've got here Dr. Jonathan Dewan, our Director of Product Management. So today we're going to just give you a quick overview of who we are, and then I'm going to hand it off to Jonathan, who will talk about the specific tools, a little bit about the technology behind it, both our legacy units and our new units. So John, you can just go to the next slide sort of as you see fit. But just quickly, who we are. Oh, so I'm sorry. So what we're going to be talking about today is, what defines end of life, right? So if you were to look at the woman on the left, sure, she's old, but would you consider her end of life? Would you consider the woman in the middle end of life? Or surely the one on the right? And so we're going to take this same analogy and we're going to apply it to batteries. And what if we could extend life, which is exactly what we're doing, right? So with batteries, many people think that they've died or they're dead, but through our technology and some of the processes that we've developed, we're able to take batteries that were otherwise destined for the graveyard or recycling, and we're able to bring 70% of that battery back and plug it back into the circular economy and give it reuse, sometimes in first life applications and other times in second life applications. So our company, A3 Global, as I mentioned, consists of A3, NuVant, and Hybrid Battery 911. We do a lot of things, but today we're going to be focusing on the future of mobility and the circular economy, specifically focusing on our hybrid and electric transportation solutions. So, although A3 Global has only been around for a couple of years, the management team comes from a history and legacy in automotive, and many of the companies that we've acquired over time, such as Hybrid Battery 911 or NuVant Systems, have been around for 10 years or longer. My business partner, Michael Cardone, comes from the Cardone family. Cardone Industries at one point was the largest remanufacturer in the United States. The family did sell that company several years ago when they reached their peak of over 5,000 employees. And then we decided to take the same principles and concepts of remanufacturing auto parts like brake calipers and things like that, but to apply it to different parts of the vehicle, which typically haven't been done over the years, such as batteries for hybrids and batteries for EVs, particularly as that population continues to grow. And so our goal is pretty simple. We want to be the industry leader in reuse, repair, and remanufacturing the 8 million tons of batteries that are currently going to waste. And we want to do that in partnership with you by lending our tools, our processes, and our technologies. And as you'll see in a couple minutes, the industry is really primed for explosive growth as more and more of these vehicles enter into the aftermarket. So I'm sure you're familiar with the circular economy, and you may have seen graphs or charts like this before. But just to show you where what we're going to talk about today fits in the whole circle, we are in the reuse repair. So if you look at the raw materials that are at the bottom, extracted from earth, many times lithium from Latin America, cobalt from Africa, that is where the entire process starts. Then it goes to design, product, manufacturing, and then use. And like all things, every product has its normal life of its use. And so when you get to the end of that, you can either send it to waste or you can find a way to reuse it or to recycle it. As you can see, when you get to recovery, you have recycle, you have remanufacturing, and you have reuse and repurpose. We do reuse and repurpose through remanufacturing, which we'll talk about here in just a couple of minutes. It's very obvious that what we're seeing in the automotive industry is really a revolution. If you look at the cars that are coming onto the market today compared to the cars that were on the market 5, 10, or 15 years ago, you're definitely seeing a lot of changes with connectivity, autonomous vehicles. More and more of those are hitting the street. I've taken Waymos several times over the past month in various cities, was just in Austin, for example. The shared economy and electrification. And when we talk about electrification, we're talking not just about EVs, but also hybrids, which are still the predominant electrification vehicle on the market. And electrification is where we're going to focus today. So I will say, for starters, a little bit of historic context that hybrids and EVs aren't new. In fact, the first car was electric, and it was 1890, and it was developed. You can see a picture of it there on the left in Des Moines, Iowa. The six-passenger wagon, which reached a whopping speed of 14 miles an hour. And then about a decade after that came the first hybrid vehicle. The only research I could find said it could only go a few kilometers. And so, again, this isn't new, but a lot has changed. Next slide, please. And so, what's old is new and what's new is old. These concepts of EVs and hybrids have been around for a very long time. But over the past 100 years, we have made tremendous progress on improving the technology, the manufacturing, the supply chain, and we're now able to make hybrid and EV cars that aren't just funny looking concept cars, but are actually designed for mainstream consumers with lower prices, good range, and they're environmentally. And so over the past 5 years or so, we've also seen really big improvements in charging infrastructure development and improvements in the power grid maturity and reliability, which has also really enabled this revolution. Layered on top of all that is the laws and regulations which have been supporting and propping up this industry to get it to a point where it's really self-sustainable. So the future is here now. Most of what we do is really focused on the aftermarket. And as you know, hybrids have been out for a long time. EVs have been out mainstream for a shorter period of time. But there's no doubt that the future is here now. And every single day, more and more and more hybrids and EVs reach that approximate 8-year point, which is for most vehicles, the original duration of the hybrid battery. And it goes into the aftermarket. And so, as you can see on the top right, only a few years ago, that was one of 7 EV commercials at the Super Bowl. And on the bottom right, you can see that in 2023, Tesla Model Y becomes the #1 selling passenger car of all passenger cars. So what does that mean? That means in 6 years from now, all of those vehicles will be coming into the aftermarket. I believe it's 8 years for Tesla. I'd have to go back and double check. But for most of the hybrids, it's 8 years. And so it's estimated by the end of this year that hybrids and EVs will account for an estimated 1/3 of all new vehicle sales. So tremendous opportunity. So looking at it a little bit different here, this goes back kind of mapping out where the aftermarket is, and this is new production by year. The bottom is the years, and that's on the x-axis, and on the y-axis on the left, you can see the number of vehicles produced each year. And if you go back to 1999, we had one vehicle that was a hybrid that came onto the market mainstream, which was the Toyota Prius. Fast forward 10 years later to 2009, there were 15 choices. Fast forward 10 years past that, there were 25 choices. And so what's happened is you've gone from really a niche consumer of, that environmentally conscious, economically prudent person to everyday consumers buying. This is hybrids here, because prices have come down and there's a lot more option. And so what you can see in the gray line is the initial hybrids that came onto the market, which were Priuses and Camrys produced per year. And you can see that that's declining. And one might say, well, does that mean that overall hybrids declined? No, actually, that was just those vehicles because they were just one type of vehicle. If you look at the overall market for hybrids, it's been growing significantly each year. But plotted against the gray is the blue line, and the blue line are the newer, larger, and luxury vehicles that are hybrids that have come into the market. And you know, of course, that especially Americans, if they have a choice for a vehicle, they're going to pick the larger vehicle because we love large things. And so what you've seen is, the 20-year-old, man or woman who bought a Prius in 2012. Well, today they're older and they have kids and they've got, crap that needs to go into the back. And, a Prius doesn't cut it for them anymore, right? So they're driving RAV4s and Highlanders. So you can see that the market has really shifted to these larger and more luxury SUVs, but which are hybrids. But the point here in showing this is that the overall market has grown. Next slide, please. And so this is, as we talked about, 8 years is like the benchmark that we look at for what's in the aftermarket. So this is both sort of real data and projected data, but these are the number of vehicles and batteries in hybrid vehicles only that are projected to come into the aftermarket. And remember, like what comes into the aftermarket this year is a reflection of what was bought 8 years ago. So, for example, we said that 1/3, and so 8 years ago, it was a small percentage of all vehicles that were sold that were hybrids, and practically none, but a very small number of EVs. And so 8 years from now, this number will be, significantly higher because of this year, 1/3 of all vehicles sold will have a battery in it. Also, what's noteworthy is, I'm sorry, if you could just go back. Also, what's really noteworthy here is the average life of all vehicles, especially cars, continues to creep up every year. So last year was another record year where I think it was, maybe like around 13 years or so that the average car stayed on the road. And that's been for a number of reasons. One, it's been because cars have become more reliable and there's more aftermarket options. Another one is more recently, and since COVID, there's been a supply chain issues, and now the issue is interest rates. With interest rates being so high, when people look at the decision of do I repair my car or do I buy a new one, and you're looking at an 8% interest rate, it's a different calculus than it was a few years ago when it was a 3% interest rate. And so for these reasons, the number of years that a car stays on the road continues to go up. But interestingly, despite the fact that that goes up, hybrid vehicles, because of the type of vehicles that they are and the type of drivers that they have who are environmentally conscious and more fiscally conservative, tend to keep their vehicles longer. So the average hybrid vehicle stayed on the road for about 15 years now, which is amazing. Looking at the EV market quickly. So if you look at the gray line there, which is all hybrids, that shows all hybrids produced each year from 2012 to 2019. And then I wanted to compare this against EVs. And I know today there's a lot more EVs on the market. In fact, today Tesla has about 50% of the market share for all EVs. And the other 50% is very fragmented and has about 12 to 15 different companies there, like Lucid, et cetera, that make up the other 15%, 50%, including traditional manufacturers like Ford and GM, for example. But using Tesla as a proxy here, especially in these years, because they were the dominant player, you can see that this really started to spike up in 2017. And in 2023, as mentioned, it became the number one selling passenger vehicle with 1.8 million on the year. But hit the space bar one more time, Jonathan, and it'll show you if I continued this chart because I ended this chart at 600,000. You can see that if I took this to 2023, sorry, it would be off the charts, right? And so that's just an interesting way to look at the how the revolution will be impacting, how today's revolution will be impacting the aftermarket in the years to come. So why is this important for all of us? Because what we do as business people in the automotive sector is we follow the money. And increasingly, if you go back to the 1970s, there has always been a portion of the total vehicle's cost which could be attributed to electronics. What's the value of the electronics inside the vehicle? And back in 1970, that was about 5%. And that you can see as cars have become more sophisticated and technology has improved, there's been more and more electronic components that are now operating these vehicles, everything from steering and brakes to radios and now batteries. And so it's projected that by 2023, that about 50% on average of a car's total cost will be in its electronics. And so that presents a tremendous opportunity for those in the aftermarket who are willing to pivot from brakes and oil changes to, diagnosing and repairing and remanufacturing electronic components and parts and batteries. Take that one step even further. Here's a couple of examples of some recent models of vehicles, which shows not the percentage of just the electronic costs like the previous slide, but this is specific to the battery, so the battery only. And you can see that in some vehicles, like if you take the Dodge Ram, for example, about 1/3 of the vehicle's total price is in the value of the battery now. And of course, this varies, quite a bit, but you can see nonetheless that it is significant. And if you go back to an ICE vehicle, maybe 10 years ago, the battery was a 12 volt, and as a percentage of the total value of the car, it was a fraction of a percent. Now it's a major chunk. And so, of course, what happens when you drive a vehicle off the lot, especially a new vehicle, is instantly the value of that vehicle drops, right? Because it has a depreciation scale, and the largest chunk of that depreciation happens as soon as it gets its first owner and comes off the lot. And so if you look at the bottom right there, you can see those arrows, and you can see over time, the relative value between the battery and the car. The vehicle price overall goes down with normal age and wear and tear. But quite often, the battery, which is anywhere between 10% to 1/3 of the vehicle cost, continues to rise because that battery is valuable. It has raw components and materials in there that can be reused or can be recycled. Think about it almost as if you buy a house. Over time, the structure of the house may begin to decompose or degrade, but certainly the value of the land will be increasing each year as land has more scarcity to it. And so it's the same sort of concept here. Next slide. So with all of this in mind, hopefully I painted a picture of where the industry has been, where it is today, and where it's going to be going. Because companies that have lived by doing changing oil and spark plugs over the past 30 years, if they don't adapt in the next 30 years, they will be out of business. So there's a tremendous opportunity here for all of us. And at this point, I'd like to hand it over to Jonathan so he can talk about some of the tools that we've developed that are available for sale, which can diagnose, repair, and recondition both nickel metal hydride batteries, which today are the predominant battery found in hybrid vehicles, and also with our new invention, the LVc40, which can do both nickel metal and lithium ion batteries. And we are seeing more lithium ion batteries start to go now into hybrids, but certainly into EVs as well. So, Jonathan, I'll hand it off to you.
Thanks, Aaron. Yes, so our focus is, like Aaron showed, really on the battery side of the hybrid and electric vehicles. So our three instruments that we have, these are our primary tools for working on hybrids and electric vehicles. We have the EVc30, that is our kind of flagship instrument that we've had. It has been around for about 8 or 9 years or so. The EVc30, it is a hybrid battery reconditioner made for reconditioning nickel metal hydride modules. Okay, up to 12 cells. The modules in the Toyota Camry Prius are about 6 cells each. And the software also includes a package that allows you to look at the diagnostic parts of the individual modules and build a battery using what we call Pack Builder. Okay. And this instrument has 30 channels on it. Our EVd40 here in the middle is a instrument primarily for power and load testing. This was developed with input from our customers about 6 or so years ago. After using the EVc30, this is kind of a vehicle simulator, we'll say. So when you connect the battery pack, it will run a high current discharge, similar to the currents that are found when you are accelerating within the hybrid vehicle. And over on the right, this is what we are really showcasing, our LVc40, the new tool we developed for servicing electric vehicle batteries and hybrids if they're lithium ion. This instrument can not only work on lithium ion cells and modules, but it can also work on nickel metal hydride modules. It's backwards compatible with those hybrid battery types. It also includes Pack Builder, and we increased the amount of channels from 30 to 40, so over like a 33% increase. So we'll kind of go over each of these instruments in a little more detail. Starting with the EVc30, we have over 200 units. I think we're about 250 now. Units are deployed worldwide. So this instrument works not only on the nickel metal hydride batteries found for the Prius Camry, but also like any Ford, any other vehicle manufacturers. We have quite a number. I think we have about 10 or 12 in Australia and a couple of these sites over here. And they have batteries that are a little bit different also, but the instrument still can recondition and process those. With the EVc30, it's simple, easy to use software. You connect the battery and to the 30 channels. The reconditioning recipes are included. Once it runs through its process, you can export any module state of health summaries. That's what SOH is. And those state of health summaries give you the parameters on each module. So it'll tell you what the capacity, the watt hour energy, the voltage, and the internal resistance is. The Pack Builder software uses all that information to then tell you which modules to pick to build your battery and how to sequence them within the battery pack. Okay. And just kind of backing up a little bit, we see that you're probably familiar with what the Toyota Prius and Camry module looks like. As I mentioned, it has 6 cells in it. So each of these kind of components or say parts are an individual cell. When you have 28 of these, that's what we call a core or pack here. It's a module set. And then once you place it within the enclosure, that's what we refer to as the battery. Okay. And how reconditioning works is during, let's say, normal operation of the hybrid vehicle, right? When you are accelerating and braking, the vehicle is using the battery, but only a small amount. So it's a very small shallow depth of discharge, meaning that you're only really using 10% of the capacity at any time. So say you're at about 70% charged. When you accelerate, it drops down a little bit. And then when you brake, it charges back up. So a large fraction of that active material, all this down here, goes unused. Because you're only going up and down within that, 70, 60, 80%, the rest of the material, the components, the nickel metal inside the battery goes unused, and what happens to it is it undergoes what we call the memory effect. And that memory effect refers to these reversible structural changes in that unused material. So physical changes start to occur. You have some grain boundaries, crystallites that form. It basically ages. Okay, so the active material that is unused develops what we call that memory effect. And we call it the memory effect because the battery, only using that small, 10, 20%, the battery eventually just remembers that it only has that 10, 20% because it doesn't use the rest of the battery. So that's how your battery starts going bad. The voltage goes down. It doesn't feel like it has enough amp hour capacity as it did when it was brand new. But luckily, this change is reversible. Okay, so our instrument uses these repeated deep charge discharge cycles down to low voltage at a very particular current, and breaks down all of those grain boundaries and crystallites and restores all of that lost amp hour capacity. It then measures those state of health parameters to the same standards as the OE, and the last step in this process is to finish the cycle to an intermediate state of charge. So that means that when we finish charging the battery, we're only putting it back to about that 80, 70%. That's because when you install it into a vehicle, if your battery is fully charged and you drive off the lot, the first time you really brake, it can't overcharge the battery, causing damage to it. Okay, so we have that at an intermediate state of charge, but all of that lost amp hour capacity is restored. An example of that is here. So this is the before and after reconditioning data for a Toyota Prius pack. Okay, so there's 28 modules. There's these 28 different lines. This is graphing your voltage over time during a discharge process. And you can see over here that some of the individual lines or some of the modules are dropping out kind of early. So you have very uneven discharge profiles. They're not all kind of stacked on top of one another. And you also get some very high internal resistances. Okay, so the factory standard for these nickel metal hydride modules is about it's about 8 milliohm. So once you get a little higher, that's when you can tell when your battery is possibly going to fail. So after reconditioning, you can see over on the right, you have a very even, balanced discharge profile with the rest, the whole pack, all of the modules, and you have very minimized internal resistances. Okay, so this is all of this data was acquired with the EVc30. With the EVd40, okay, so this is what I refer to as the power tester. You submit all of your modules to the high current discharge. So after reconditioning, after assembling your modules in the correct order and building them into a pack, you will connect that pack to the EVd40. And the EVd40 really, like I said, is a vehicle simulator. So it runs, either a 30-second, 1 minute pulse where it discharges those modules, and you can see if any modules voltages really drop out early. Okay, so you might not be able to see that, let's say, failure on the EVc30 because of the currents we use. So the currents were up to about 5 amps or so, and that's just due to the instrument. Here, you're having currents up to about 50 amps, and so you will see if any of those modules drop out. Okay. We also have a built-in sophisticated power supply that allows you to recharge all of those modules back up with CC/CV capability, which is constant current, constant voltage. Here is an example of what that power test data looks like. This is a 30-second discharge. And so you can see that, there's 34 modules and most of them kind of follow along the correct line during it. However, you do have these 2 weak modules that need to be replaced after the test, okay, before recharging back up, installing new modules, and using the pack builder. So you use pack builder to figure out which modules you need to install, and then you can retest this battery pack. This here shows kind of a simple outline of what the battery workflow system looks like. So we're starting over here on the left with the battery cores. Okay, and that's what you should be familiar with. Those are kind of batteries that have come from junkyard suppliers that have all of the electronic components and everything connected. You need to disassemble it and attach only the modules. Once you recondition the modules on the EVc30, you'll have all of the data of those state of health parameters, and then place it onto your module inventory, okay, on the shelf. And from there, you'll use the battery pack builder to select which 28 modules or 34 modules of your whole inventory will build the best pack. Then put the pack on the EVd40, make sure none of the modules individually are weak, and then you can finish building the complete battery with all the electronic components and harness and bus bars together. Once you install that into your customer vehicle, you should receive a core back that goes in the battery core. So it's very circular, okay? So this primarily was focused on the nickel metal hydride. Now let's kind of turn a little bit and take a look at how lithium ion works. So lithium ion batteries require the CC/CV charging. That's constant current, constant voltage. That means when you approach the kind of final voltage for the lithium ion battery, that cell, you need to taper the voltage down and hold the cell at that voltage. Okay, so you can't just charge it at 5 amps and then once it hits it needs to hit that voltage and then taper off, hit it again, taper off. And that's kind of what we're doing with this mimic that you can see here. And this has been incorporated, and it's different from the nickel metal hydride modules. This has been incorporated into our new LVc40. Okay, 40 modules. We're very excited about this. We've used it to not recondition, but test Camry, Prius. We're looking at the Hyundai Sonata. We're looking at a couple of different other lithium-ion battery types, but we have successfully processed those cells for the Prius hybrid lithium-ion and Camry hybrid lithium-ion and the Ford Fusion hybrid lithium-ion and installed those in the vehicles, and they're still running today. So with the LVc40, again, you can test lithium-ion cells, and it is also backwards compatible with those nickel metal hydride modules. Okay, so you can recondition those also. It can handle lithium-ion cells anywhere from 3.7 volts up to the larger nickel metal hydride modules. All right. Down below, you can see this is kind of a partial list. We're still adding more and more battery types today, but this kind of shows the Prius, the Fusion, the Camry. All of these have been successfully processed and worked through with the LVc40 installed into vehicles. As a little overview of what the process would look like. So for the Camry hybrid, this is the latest generation with lithium-ion cells in it. There are 70 cells total. Okay, so two, say, kind of groups of 35. You would use the LVc40, run the capacity test. It would identify any low capacity modules or cells, low capacity cells, which would then need to be replaced. And from there, you would then run the next 35, and all of those cells pass or if you need to replace any. Combine both sets, and that's how you kind of build your battery from there. Okay, so it's really the identifying poor performance cells and replacing those with either new cells, or really you need cells that are similar in performance to the ones that are currently there. So a lot of times you can't just pull a brand new cell off the shelf if you ordered some, because they would be higher in value, higher in capacity, and so you need to make sure that your pack and set of modules is very balanced. Again, this is just a list of like process vehicles. We're still adding more vehicles today to the lithium ion, the LVc40 list. But from there, I would kind of direct you to our website if you want to look a little more at those products. We have a resource center. We have a monthly newsletter, the blog. A lot of these webinar videos are available on our YouTube page, so you can go back and look at the EVc30 or look at the pack builder. And with that, I want to thank you for attending, and we'll be happy to answer any questions. If you have any questions, you can either type into the chat or unmute yourself because there's only a couple attendees right now.
We'll also be sharing the link to the recording on YouTube with everyone afterwards.
Okay. If we don't have any, oh, here we go. We have a question. Internal resistance. So the internal resistance of the module or cell is the kind of opposition of flow. So it's measured in ohms, and it's a characteristic of the battery, and you want the internal resistance of that module or cell to be low enough to allow charge and current to travel through. That's why it's around like 8. It's on the order of milliohms. Because if it's too high, that means that there's either electrical like disconnect, something's insulated. But if it's too low, that means that your cell is kind of short-circuited and dead. So the internal resistance is a characteristic of the battery that shows how easily it charges and discharges electricity through its terminals. It's a good question. Thank you for the question. Okay, if there's no more questions, please reach out if any questions do come up, either through email or give us a call. There's Aaron's email there, mine, and our phone number. Okay, and we will kind of reach out and provide the video of this recording to everyone. But again, thank you very much, and have a great day. Thanks, everyone.
Take care, everyone.